Hello and welcome to my instructional video for proving and using the area formula for a circle. So we're going to explore where the area formula comes from, and we're going to practice applying it to some situations that might be useful. So there's this really cool site called GeoGebraTube in which it gives the user the ability to kind of manipulate and tinker with some shapes. So as you can see here, we have a circle. It's dissected into 9 parts, and we have the ability to dissect it into fewer or more parts. I like to do more because you can see how as it approaches infinity, it'd be solid. And then notice we are given the radius in red, and then green on the outside is representative of the circumference. So many of us hopefully know that pi is equal to the ratio of the circumference to diameter, and that the circumference equation is pi times the diameter, or 2 times pi times r. So watch what happens when we unroll this. So we unroll the circle and it makes a triangle, which is really cool. So the next thing we need to ask ourselves is, why is this useful? Well, some things I want you to notice again. Here's the circumference formula, 2 pi r. The circumference is now the base of this triangle. And then the radius is the height. The radius is from the center of the circle to the outside. So what's really cool here is next we're going to change this triangle into a rectangle by halving the base. So if we cut this 2 pi r in half, we're actually left with just pi r. And here's what that would look like. See, we cut it in half. So now we have a base of just pi times the radius. And if we did pi times the radius for the base of a rectangle times the radius for the height of the rectangle, which is the area of a rectangle equation, base times height, we would get area equals pi r squared. So if area equals pi r squared for this rectangle here, we also know that area equals pi r squared for this circle. So that's the formula we're going to use, area equals pi r squared. What we have here is just a really clean and simple version of the area formula for a circle now that we've proved it. What I'd really like you to do is write down this equation. The equation is right here. Area equals pi times the radius squared. And you might even want to write down this little circle if you're taking notes, just so that everybody's clear what the radius is. The radius is from the center of the circle to the outside. So as you can see here, the center to the outside. That's the only value you need to find the area of a circle, which is pretty nice. So what I would like to do with you now is just run over this area formula with somewhat of a real-world application problem. This is taken right from our textbook, so feel free to look there for the work as well. So we have a biscuit recipe. It calls for enough dough to be rolled out and circles to be cut out. That's important. We need to know that there's circles. And there's a biscuit cutter, which has a radius of 4 centimeters. They want us to find the area and use 3.14 for the number pi. So when I get story problems in geometry, I like to start by just drawing a picture of my situation. And this is it. I have a circle cookie cutter with a radius of 4 centimeters. Next thing I do is I always write the equation I'm going to use down. It helps keep organized, and it says, what do I need to know to answer this? So in this case, I really need to know what the radius is. The radius is 4, so this is actually pretty nice. Area equals pi times 4 squared, which also tells us 4 squared can be simplified to 16 pi. Now the reason I'm writing this as 16 pi for you is 16 pi is actually an answer that you could be asked for. Notice right here it says use 3.14 for pi. The reason they tell you to do that is pi is an irrational number. It goes on forever, and you can't actually write that number down. So if you ever needed an exact answer, or you might hear a textbook say something like, in terms of pi, this would be a great exact answer. 16 pi is exactly the area of that circle. However, it's kind of hard to wrap your head around this, and the directions tell you to solve using 3.14 for pi. If we did that, we'd have 50.24 square centimeters. And that's a little easier to wrap our heads around, and we're following the directions indicated by the problem itself. So right here is where I would say that the rubber meets the road. Another application I have is for pizza prices. So this is actually a screenshot from the menu at Andrea's Pizza on Boston, which is a popular spot in East Grand Rapids. And I am showing the price here for one topping for a 10-inch small and one topping for a 12-inch medium. And those inches that they're noting up here, those are measured by the diameter of the pizza. So that's how pizza is measured. So what I'd like to do is run through how to get the area of each of them, and then you can make a decision maybe based on value which pizza you would prefer. So let's find the area of the small one first. If the diameter is 10, the radius is 5. So A equals pi r squared. That would give us an area of 25 pi. And if we multiply that by 3.14, we get an area of 78.5 square centimeters. Okay, let's look at the medium. The difference for the medium is that the radius would be 6. If the diameter is 12, the radius is 6. That gives us an area of 36 pi, and if I use 3.14 as an estimate, we get 113.04 square centimeters. So it looks like a big jump, and in fact, we can use some of our knowledge from a previous unit on how to find percent change by amount of change divided by the original. To do that, I'm not going to write it all out, but to do that, we could do the new amount minus the old amount divided by the old amount. So 113.04 minus 78.5, divide all that by 78.5. We actually get a 44% increase in size for just those 2 inches. It's amazing. Okay. Then, the other thing you can do is find the price per square inch. So what I did was I took the price and divided by the number of square inches, and the price per square inch for the smaller pizza is 12 cents per square inch, and for the larger pizza it was 10 cents per square inch, which shows you that it is also a better deal for the medium pizza. Then lastly, I also did a percent change equation for the change in price, because if it's a 44% increase in size, if it's also a 44% increase in price, it's not really a greater deal. So if we took 11.15, I'll show you where I got these. If we took 11.15 minus 9.30 and then divide that by 9.30, we find a percent change in price to be 20% increase in price. So what this really means is for 20% more money, you get 44% more pizza, which to me seems like the better deal. We should probably buy the medium. Unless, I guess, you're not hungry or something. So thank you for watching my instructional video for proving and using the area formula for a circle. Hopefully it gives you a little better insight as to why we use the area formula that we have. And then hopefully you can help you apply it to some real life situations like buying pizza. And it also may give you some incentive to really get excited for Pi Day, which is March 14th, 3.14. Lastly, I'd like to recognize my.hrw.com, or the whole McDougall website, for their use of graphics through our online textbook, as well as Andrea's Pizza and their online menu for us to really use an example to dig in hard. So thank you for the use of those resources.